we're going to discuss the first law of thermodynamics. And the first law of thermodynamics will state that the change in energy is going to be given as a change in internal energy, a change in kinetic energy, a change in potential energy, and this will generate work, heat, and probably there is some mass. But when we're talking about closed systems, and these systems are, for instance, stationary systems, the term of kinetic energy and potential energy will not really vary, because that's the definition of a stationary system. And the first law of thermodynamics will state then that a change in internal energy is going to be equal to work plus heat. We usually analyze processes, and for instance, the change in internal energy in a process is going to be what is called an state function. A state function is a function when we have a process, for instance, the process can go from one place, that's one state, to another state in any process. It can go by one path, it can go by the other. We don't really care actually, because the state function only cares about the initial state and the final state, and the difference between both of them. So for instance, volume is a state function because you only care about how the volume changed, final minus initial. The same, for instance, is with internal energy. You only care about how internal energy changed, final minus initial. So that's a state function. But whenever we're talking about path functions, you do care how this guy, what that guy did in a path. So for instance, work and heat are path functions. And work, if you have, for instance, a PV diagram, work is going to be equal to the integral of PdV. And this work, which is the integral of PdV, since it's an integral, is the area below the curve. So, for instance, the blue pad has more work than the green pad in this example, because the area below the curve is different. So that's a path function, and heat is also a path function. When we're talking about thermodynamic work, or the moving boundary work, that's integral of PdV from V1 to V2. And for instance, we can do the integral, but since this is going to be evaluated from V2 to V1, and there is going to be a difference here, then if V2 is larger than V1, this is expansion, for instance, the expansion has a positive work. And the other way around, if it is compression, compression deals with a negative work. So in this sense, if you have a system, in the system you can compress the system, that's a work that it's in the system, that you're compressing the system, you're introducing energy, but that's a negative work. So introducing energy is negative, and that the system performs work is positive. But when we're talking about heat, introducing heat is positive, it's gaining energy, and losing heat is negative, so it's the other way around. So in that case, we can define the first law as change in internal energy equals heat minus work. This minus comes because of this difference in sign in the work. Negative work, for instance, will increase the internal energy. So negative times negative will give positive, and the other way around. Positive work is work that will exhaust energy from the system, so the internal energy will decrease. So that's the reason for this negative sign here. So this is the first law of thermodynamics in a closed system.